Dealing with errors. This is section 2.2 in our textbook. And whenever we're doing measurements, error can always be involved. It can either be the fact where it's just a human error, where you've made a mistake with the measurement, or that perhaps there's something wrong with the measurement scale itself. We have names for those different types of errors. We call something a random error if it's inherent in the unpredictable events of a measurement process. They occur because of random and inherent unpredictable events. Systematic errors, on the other hand, are something when there's a problem with the tool, the measurement itself, and it affects every single measurement that's taken. Other considerations with errors is we actually want to quantify them. So we want to say, well, is this a big error or a little error? And we'd like to be able to make a decision on that. So we talk about an absolute error is when we just take the claim value, whatever that may be, subtract it from the true value, and that's going to give us the difference. And we're going to call that difference the absolute error. That's how far it's off by. Now, a relative error, it's going to tell us, it compares the size of the error. You know, how big is this error as a percent? So we have a formulas for calculating that. For the absolute error, it's just subtracting. The claim value minus the true value gives you the absolute error. Then we can take that value, the absolute value, divide it by the true value and get a percent. And so then we can actually talk about how big, how far out of whack is this measurement. And what we're going to look at in the question in just a minute is this idea of, is our measurement accurate or is it precise? Is it one or the other or both? And just to kind of get a common sense of what we're talking about, we're going to say a measurement is accurate if it's closely approximates the true value. If I say that my dog weighs 65 pounds and she actually weighs 64 pounds, then that's pretty close. That's a fairly accurate amount. Precision deals with the amount of detail in a measurement. So if I say that my dog weighs 60.001 pounds, that's a very precise measurement, but it's not very accurate if she weighs 64. It's off quite a bit. So let's take a look at the question that we are dealing with in this section. This is section 2.2. Let me scooch it up so we can see the whole question. Okay, so the question says, a standard weight defined to represent exactly 5.00002 kilograms is kept by the Government Institute of Standards. Assume that the weight is put on a scale and the weight is recorded as 5 kilograms. Describe the accuracy and precision of the recorded weight. So first, let's talk about the accuracy. So if it actually weighs 5.00002 and we weigh it at 5 kilograms, then that's fairly accurate. We're pretty close to the real value. So we're going to say the recorded weight is accurate because of the relative error of the measurement is large. No, that doesn't make sense. The recorded weight is accurate because it has many decimal places. No, actually it doesn't. The recorded weight is accurate because the relative error of the measurement is small. Let's revisit that. The relative error, meaning the difference. No, that's relative error is not what we're looking at. We're looking at absolute error. Keep going. The recorded weight is not accurate. I disagree, it is accurate. The recorded weight is not accurate. Forget that one. F. The recorded weight is accurate because it does not have many decimal places. Well, so far I didn't like any of these. So which one? The one that I liked the most is C. It said the recorded weight is accurate because the relative error of the measurement is small. And that is true. If we divided and multiplied by 100, we would get a small one. So let's choose C. Great, good job. And now let's talk about precision. Describe the precision of the recorded weight. Now remember, the recorded weight is 5 with no decimals. The actual weight has 5 decimal places. So the recorded weight is precise because it has many decimal places. No, it doesn't. The recorded weight is not precise because it has many decimal places. Well, that doesn't make sense. The recorded weight is precise because the relative error of the measurement is small. The recorded weight is not precise. Remember, we're not comparing here. We're just looking at how many decimal places. The recorded weight is not precise because the relative error of the measurement is large. No. The recorded weight is not precise because the relative error of the measurement is small. No. The recorded weight is precise because the relative error of the measurement is large. No. The recorded weight is precise because it does not have many decimal places. If that said not precise, I'd like it, but it doesn't say that. The recorded weight is not precise because it does not have many decimal places. Ding, 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 ding. It's H. So the moral of this story is that when you're doing these problems, it's not really about the kind of math that you're used to with algebra. It's about words. It's about understanding what the vocabulary means and applying it in a situation. Keep working, keep studying, and you'll do well on the test. Till then, goodbye.